Hey everybody, Mr. Smith here. In this video, we're going to talk about factoring and solving quadratic equations. This is going to be a really important thing for us, not only in this class, but in whatever math class you take next, whether it's pre-calc, college algebra, college trig, anything at all. You are going to need to know how to do this factoring business. Okay, so I can't emphasize enough how significant this idea is going to be for you moving forward. Right? So I'm going to try to break it down and make it very simple for you in this video, and we're going to take a lot of time to practice it ourselves in class. Okay, so let's dive in first and just talk about something that I'm sure you're familiar with, and that is the idea of finding a common factor in an expression, or factoring out a greatest common factor, or a GCF, which maybe you remember from Algebra 1 a little bit. Basically, what I'm going to do in this first example, what I'm going to do is look at each of my terms, and I'm going to ask myself, is there something that I could divide each one of these terms by? Okay, so I'm looking at 7p squared, I'm looking at 21. I see that 7 and 21 are both divisible by 7. So I say, hey, I could factor a 7 out of that. So I divide everything by 7. I'm pulling a 7 out to the very beginning, and I divide each of these terms by 7 one at a time. So 7p squared divided by 7 just is p squared. And 21 divided by 7 is 3. Okay? I know you can always check yourself to see if you did it right. If I distributed this thing back in there, 7 times p squared is 7p squared, and 7 times 3 is 21. And that's exactly where I started, right? So now I know that I did it right. Let's do one with 3 terms. Okay? Let's do this second example right here. This has 3 terms, okay? They each have a coefficient, so I'm going to look at each of those coefficients, 4, 20, and negative 12. I'm going to ask myself the same question. What is the biggest number that I could divide all those things by? Well, they're all divisible by 4, okay? So I'm going to factor a 4 out from each piece and divide each one of these terms by 4 individually. So 4x squared divided by 4 is x squared. 20x divided by 4, 20 divided by 4 is 5, and I still have that x attached to it. And negative 12 divided by 4 is a negative 3. So that's how I would do that one. And I'll show you one more example. Let's just do this one for a second time. Well, again, I look at each of my terms, and I ask myself, what's the biggest thing I could divide those by? The coefficients are 4 and 2. Those are both divisible by 2, so I'm going to take a 2 out. You might also notice that both of these terms have a w. And if every term has a variable, I could also factor out variables, all right? And since both of these have a w, I want to ask myself, what's the most amount of w's that I could take out? Well, this one just has 1 w. This one has 2 w's, okay? So they all have at least 1 w, so that means I could take out a w as well. So I'm going to divide each of these terms by 2w. 4w squared divided by 2w, well, 4 divided by 2 is 2. And w squared divided by w, that looks like this. Think about your exponent rule a little bit. 2 minus 1 is just w. And 2w divided by 2w is just 1. And that's what we're going to do. So this is a brief intro. We're going to need to use GCFs a little bit more moving forward. So I just want to show you a couple of those examples to jog your memory a little bit. So let's get into the main thing for this video, and that is factoring quadratics in standard form. All right, so we are dealing with quadratics that are ax squared plus bx plus c primarily, and there's really 2 cases that we're going to deal with. The first one is when my leading coefficient is a 1. So notice how in all these examples, my leading coefficient, the very first number, is a 1. All right, when that's the case, when you have the leading coefficient of 1, that's kind of your easier case, all right? So what we want to do is factor each of these. And really what factoring is, all that means is that we are going to take something, an equation, and we are going to rewrite it as a product of a couple of things being multiplied together. We're breaking it down into some pieces that are being multiplied together. That's what factoring is, okay? So let's do this first one first. I am going to show you the process that we're going to run through. Okay, so Bear with me as I go through it, and I promise we're going to practice this thing as we come back to class a little bit more. What we're going to do first, I'm going to multiply the A value times the C value, the first number times the last number. Remember, the first number is a 1. 1 times negative 18 is negative 18. Okay? And now, here's what I need. I need to sit back and I need to find two numbers that multiply. I need to find two numbers that multiply to negative 18, that number that I just got there, and two numbers that also add to negative 7, my middle term. So I need two numbers that when I multiply them together, I get negative 18, and when I add them together, I get negative 7. So if that's hard for you to come up with, I think it's helpful to just go write out our factors of negative 18. Okay, we got 1 and 18. Of course, one of them would need to be negative, but I'm not going to be able to combine those to get a 7. I've got 2 and 9, and that might work somehow, right? Because one of them is going to need to be negative in order to multiply to negative 18. And I need to get a negative 7 out of that too. So what if I did negative 9 and positive 2? Negative 9 times positive 2 is negative 18, and negative 9 plus 2 is negative 7. So that's going to work for me, right? So my two numbers are going to be 2 and negative 9. All right? Once I get my two numbers, and this only applies for the easy case when A is 1. Once I get my two numbers, I am just going to rewrite my initial equation as some things being multiplied together. Two terms being multiplied together. It's going to be x plus my first number, 2, and x plus my second number. Since it's a minus 9, I know it's just going to be x plus minus 9, which is the same thing as x minus 9. And this is going to be where I end. Okay? You could check yourself out. If you double distributed this expression, you would end up right back where we started. Okay? For sake of time, I'm not going to do that. But if you want to try it on your own, go ahead and do it. If you check yourself, you should end right back up where we started. Let's do one more example, and then I'll show you a more difficult case. Do the second example. So again, our first step is multiply A times C, first times last. That's negative 14. Now I need two numbers that multiply to negative 14 and add to negative 5. Okay? So maybe you can think of factors of negative 14. We have 1 and 14. That's obviously not going to work. I can't make 5 out of that. We have 2 and 7, and that might work. I need one of them to be negative. Okay? So what if we did negative 7 and 2? Negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. So that's going to work for me. So my two numbers are 2 and negative 7. So I'm going to rewrite my expression. Two pieces. It's going to be x plus 2 and x minus 7. And this is where we end. Again, all I'm doing is I'm taking this initial equation and factoring. All it is I'm taking this equation, I'm breaking it down and rewriting it as two things that are being multiplied together. That's the whole goal. Okay. So there's a couple examples of our easy case. Case 1, when the leading coefficient is a 1. Let's think about what happens when the leading coefficient is not a 1. Okay, so this is our more difficult case, when the leading coefficient is not 1. So notice how all of these A values are something other than 1. What do we do in this case? I'll show you. It's a little bit longer of a process, but I'll work you guys through it and try to make it simple. We're going to start the same way we started the other one. A times C. So 2 times 12, that's 24. Now we're still going to do the exact same thing. I need two numbers that multiply to 24 and add to 11. Two numbers that multiply to 24 and add to 11. So I'm thinking of factors of 24. 1 and 24 aren't going to work. 2 and 12 is close, but that's not going to work. 3 and 8 works, right? 3 times 8 is 24, and 3 plus 8 is 11. So my two numbers are going to be 3 and 8. At this point, this is where it gets different. When we were in the easy case, we just took these two numbers and we were done. Now that a is something other than 1, I'm going to have to do something different. What I'm going to do, this might seem weird at first, so just bear with me. What I'm going to do is I'm going to take my initial equation, I am going to rewrite it, except instead of using 11x, I'm going to use these two numbers, okay? Because 3 and 8 make 11. So it'll look like this. 2x squared plus 3x instead of 11x plus 8x plus 12. Notice how this and my first equation are really the exact same thing. I've just taken 11x and broken it up into 3x and 8x. And now what I'm going to do, again, bear with me on the process. It might feel kind of weird. I'm going to break this up into two halves, two groups. We call this factoring by grouping. I'm going to look at each one of these halves one at a time and factor a GCF out of both of them. Okay? So my first one, 2x squared plus 3x. I look at that and I ask myself, what is something I can divide out of both of those? Well, there's nothing I can divide out of 2 and 3, but they do both have an x. So I could divide an x out of both of these things. It's going to be x times 2x squared divided by x is 2x, and 3x divided by x is 3. Okay. And now I'm going to do the exact same thing in my second half. I'm going to look at that and ask myself, what can I divide out of that? Okay. But here's the trick. Whatever I factor out of this, I want it to end up looking just like this. I want it to end up being 2x plus 3. So first, let's just think about what I could divide out. I've got 8 and I've got 12. They both don't, both of them do not have an x. They don't both have an x, so I know I can't take out a variable. But I can divide both of these things by 4. 4 goes into 8 and 4 goes into 12, and that's the biggest thing that goes into both of them. So if I take out a 4, it's going to turn into 2x plus 3. And notice how those are exactly the same, and that's what I want. I want these to match. I want these to match each other, okay? Here's what we're going to do now. My final answer is going to be the common factor between these two pieces, so 2x plus 3, times the two GCFs that I pulled out put together into one. So it's going to be x plus 4. This will be my final answer. So I took my repeated factor and I took my two GCFs, I put them into one, and that is going to be my final answer. Okay? Yeah. Let's do one more example here, and then we'll keep moving. We'll almost wrap this video up. We'll do this example. Then we start by multiplying a times c. 2 times 6 is 12. Okay. Two numbers that multiply to 12 and add to -7. Well, 1 and 12 isn't going to work. 2 and 6 isn't going to work, but we might be able to use 3 and 4. Just remember, it needs to add to a -7. So what if we did -3, -4? Those two things multiply to 12, and they add to -7, right? So those are going to be my two numbers. So I'm going to rewrite this equation with these numbers, 2x squared minus 3x minus 4x plus 6. Same way I did before, break it up into two groups. Look at the first one and see what can I pull out of that. Well, I could take an x out, just like before. It's going to get 2x minus 3. I look at the next one. And remember, I want this to end up matching 2x minus 3. So whatever I pull out of this, I need it to match 2x minus 3. Notice how the signs are off right now. This first term is a negative, second term is a positive. That tells me that I need to factor out a negative here in order to make it match. Okay? So they're both divisible by 2, but in order to make it match, I need to flip those signs. That means I need to factor out a -2. 4 divided by -2, that is positive 2x. And 6 divided by -2 is -3. Notice how that accomplished what I wanted. That made these things match. Okay? So my final answer is going to be my two common factors, 2x minus 3 times the 2 GCFs. X minus 2. And then we're done with that problem. All right. Just a couple more quick things I want to share with you in this video, really 2 more examples, and then we will be done with this video. So, a couple things to keep in mind, a couple shortcuts. In this first example, if you can take out a GCF at the very beginning, before you factor, you definitely want to do that. So if I look at this quadratic, I notice that there's a 3, a 15, and a 12. Those are all divisible by 3. So if you can take out a GCF, go ahead and do that. That's going to make life a lot easier. So I could divide all these things by 3. And turn it into x squared plus 5x plus 4. And now factoring this middle piece will not be as bad, right? Because now it's a case 1. The leading coefficient is 1. So if I multiply a times c, that's 4. I need 2 numbers that multiply to 4 and add to 5. We'll think about it for a second. That can just be 4 and 1. So then I'll just rewrite this thing in parentheses as x plus 4 times x plus 1, just like those first examples that we did. That 3 at the beginning just stays out the front. I didn't do anything with that. It just stuck with me the whole way. And that would be my final answer. Okay. And one last thing here to wrap up this video. This last example, 4x squared minus 81. This looks a little bit different because I'm missing a middle term. This is something that we call the difference of squares. Difference of squares. Okay. When you have something like this, there's a simple equation that we can use to factor this. The equation looks like this. A plus b times a minus b. All we have to do is figure out what a and b are. And in order to do that, I need to notice that both of these terms are made up of perfect square numbers, meaning they have clear square roots. They have even square roots. Right? So I'm going to ask myself, what are the square roots of these 2 terms? How can I rewrite 4x squared as something being squared? And how can I rewrite 81 as something being squared? Well, 4x squared, I could think of that. As 2x squared, right? If I did 2x times 2x, that would get me 4x squared. And I could think of 81 as obviously 9 squared. So the square root of 81 is 9, right? So I'm just rewriting these things as something squared, trying to figure out what the square roots of these things are, all right? And now, here's where this equation comes back in. We think of this as a squared minus b squared. So that means that a is 2x and b is 9. So I can take these things and plug them in for a and b in this first equation. So it's going to look like this. A is 2x, b is 9, so it's 2x plus 9 times 2x minus 9. And this is going to be the end of this problem. That's where we wrap up. All right, so I promise we're going to practice these things in class. This video is just meant to give you a little introduction about how these things work. So like I said, factoring is important. If you're confused about any of these processes, go ahead and try to watch it again. Come with questions in class tomorrow, and we will practice them until we feel good about it. If you guys have any questions, feel free to email me, and we will see you next time.